I know everyone is talking now about AI, and it's very interesting. It's the future, but for now, maybe let's keep our foot on the ball, as they say, and talk about the current threats that are coming. Talk about specifically what is the issue now, not what's waiting for us. And of course, to start with that, we'll start with a bit of a history lesson. I know my colleague already covered this slide, but it's a very interesting slide, and we have a saying in my mother language, I'm Croatian, ponavljanje je majka znanja, or as they would say in English, repetition is the mother of all knowledge. So let's repeat a bit. It's always good to know, where we started with security, how the infrastructure, the applications evolved. And when we look at this slide, we can clearly see, like in the beginning, in the 90s, 2000s, I was a bit maybe young then to remember, but the applications were very simple. The servers were small, not as powerful as now. The attacks were a lot simpler. It started with DDoS attacks. It was very easy to open 50,000 connections back then. There was no load balancing or anything. Or use all the connections on the server, and basically the application is not working. And the attacks, as I said, weren't that complicated. As the industry progressed, more people were using internet. There was a monetary incentive behind it, of course. After a while, to launch more sophisticated attacks, there were attack groups that were making money out of it. So the attacks were, of course, increasing in size and sophistication, and we needed better solutions to protect these simple web pages, web applications. That's where we started with the WAF, with the bot protection and stuff like that. But as we know, in the 2000s, 2010s, the applications developed, the infrastructure, the architecture of applications changed, developed more. We're talking now about microservices. We're talking now mostly about APIs. So most applications are no longer static-based. They are API-based. Everything is talking APIs now. And my colleague covered most of this already. But the main point is the economy is now in the API sector. And the third wave that is coming that we see here is the agents, the AI. It will come. We need to be prepared for this. But the main point is, from the architectural standpoint, we're still somewhere over here. But especially in the region, I come from Croatia, I would say it's similar as here. From the security standpoint, we're still somewhere over here with the WAF. So maybe show of hands, who here has a WAF solution implemented in their organization? Anybody? WAF? Nobody. Wow. So I don't even need to ask about API security or API protection, because I imagine not even this is implemented if you don't have WAF. The main point is you have applications that are publicly available, and you don't have protections that are able to cover this. The infrastructure changed. The WAF is no longer enough to protect the modern threats. The WAF was built to protect static applications. Now we're talking about APIs and microservices that work a bit differently. And if you're trying to use a WAF to protect APIs, it's not going to work. It's not going to happen. It's not enough. The technology in the background changed. We need a security solution that is able to keep up with this. That's why the main focus will be on the API security for this presentation. And why is this important, especially now? We see a great increase in application layer attacks. And this increase is, of course, targeting more sophisticated, using more sophisticated attacks. So SQL injections, cross-site scriptings, stuff that WAF was protecting from is decreasing actually. And we see an increase in 0 days in vulnerability exploits. And all of this is fueled by AI. This is the main problem now we see with AI, because it's very easy to run sophisticated attacks. Before you would need to have an ATP group, expert to find vulnerabilities, to find 0 days, to prepare an attack campaign. Most of the script kiddies were using like SQL injections, cross-site scripting stuff to try something, and WAF was able to cover it. Now with AI, the AI can find vulnerabilities for you. It can build the attack campaign and can actually infect the web application. Okay, now maybe you're thinking, okay, but it's not that easy. I maybe tried putting in ChatGPT to write a ransomware or a script that's gonna attack a site or look for vulnerabilities in a website. And of course, ChatGPT told you, no, I can't do this, this is not permitted. And yeah, but there are options to bypass the guardrails, as they call it, of even the major providers. It can be quite easily found on even on Reddit forums, not even on the dark web. But that's not the only problem. With the rise of AI, there is now even basically SaaS services or AI models that you can buy or rent that are without guardrails, that are being used by black hats, that can write the attack campaigns for you, that can scan for vulnerabilities. And this is what we're up against. So now the attackers have these tools that are able to generate the attacks for anyone. You don't need to be an expert. It's going to generate the scripts, find the vulnerabilities in specific applications, run the attacks for you. And this is what we need to be able to protect against. That's why we see this such a big increase in the 0 days in the vulnerability attacks, because the attacks are getting better and smarter. And generally, something that's also maybe a lot of people don't maybe realize or understand with web applications. And maybe one of the reasons why none of you put your hand up when I asked about web application firewalls. All of you, and I know all of you, have externally exposed application. Everyone has applications. Either you're a bank, e-commerce, government site, gas, oil. You're probably connected, let's say, electrical with the European grid. You're communicating through APIs with other European distributors. Everything that's publicly exposed can be used as an attack vector. And trust me, it's very simple. We have labs that do it. We see it in the wild. Through this web application, people can take control of the server in the backend. So this server is sitting somewhere in the DMZ or in the LAN. And I can, through the browser, run basically, if I have a 0-day or an exploit, or if it's not protected properly, I can run commands in the shell on the server. I can open a backdoor through the web application from the server to my command and control center, get into your network through this exposed application, because the application is exposed. This can be, and this is what the attackers are using as the initial vector to establish a foothold. So you need to have a way to protect the web applications. You know, it's not just about think, okay, maybe they'll attack a DDoS, the application will not work. That's a problem. But it can be an even bigger problem because it can be used to establish an initial foothold. It can be part of a very larger threat campaign. Just something to keep in mind. But now let's talk about the security and how are we able to protect these web applications, especially the new generation of web applications that are mostly speaking APIs. And to be able to protect API-based applications, we need to have an API security solution. Makes sense? Yeah. Why? Because, again, 80–90% of applications today speak API. I would say almost 100% applications today are talking or have some APIs exposed, and that's a fact. And what's different about APIs? So APIs are cool because unlike traditional web pages that were configured, either each developer wrote his own code, APIs are very structured and they have specific rules how they are used, how they are consumed. And we can use this for our advantage in our solutions. But before we talk about how can we protect them, let's talk about the attacks. Why are the API attacks a bit different from the WAFs? Basically, we have three separate pillars, three separate types of attacks. The first ones are the embedded attacks. And you can see in the first one is the SQL injections. And yeah, this is something that WAF can cover. So you have WAF, you will be able to protect against injections, stuff that's inside the HTTP header of the API. But they're using, it's not just the HTTP. APIs, as I said, are very structured. Most APIs are authenticated. They use JWT tokens authentication. WAF is not able to detect and check if the authentication, if the JVT tokens are correct, whereas in an API solution, we are able to do that. So API attacks are also targeting the authentication layer. They are targeting insecure endpoints that are maybe should be authenticated but are not, and that's something they can exploit. On the other side, we have the DDoS attacks, which my colleagues was covering. So DDoS, again, the WAF is blind to the DDoS because it's legitimate traffic, it's just a lot of traffic. And for APIs, it's an even bigger issue because with APIs, the attacker can, with a very small request, generate a lot of traffic, not even traffic, consume a lot of resources on the backend. Think of it like this: you have a banking app, and you open the banking app, and you want to get a statement for the last 10 years transactions in your account. The request to get this is very small. It's just get statements from this date to this date. Very small. The response, the server, the database in the backend needs to generate a very big response, a document, do a lot of CPU processing. For this one small request, a lot of CPU is being used. And then you just amplify it, you just repeat this request constantly. So with very little requests, you can bring down the server. And the final attack vector, and this is the most important one, is business logic attacks. So instead of the traditional WAF, which is using some vulnerability exploit, this is targeting your specific application. So each application has their own business logic, and attackers, especially now with AI tools, are able to manipulate and abuse the business logic. So maybe you built the application in a way and you didn't think it could be abused, and the attackers are able to abuse it. I understand maybe you didn't catch what I was saying, and the perfect example to explain business logic attacks is through examples. Because when I was first also learning about business logic attacks, it was like, what is this? How is this working? How is this different from the normal injections or vulnerabilities? But it's very different. And that's the main problem, and that's something that WAF is not able to cover. So in regards to business logic attacks, as I said, a few examples just for you to maybe understand. The first one, like a generic one. Now it's almost summer, and a lot of you are maybe booking vacations to go to the sea on the coast, and you have the booking or travel site, and you find a hotel that's very nice, and they are having a promotion, 20% off for this hotel in June. Perfect. You write the coupon code or the voucher travel20, and you get 20% off. That's very nice. But then maybe the developers didn't think about this code being reused and exploited. So when you apply this code, what's happening in the background in the application, there is basically a post request coming to the backend server that's saying, post apply this travel20 coupon. Very simple. What if I repeat this request? I use Postman, I just send it again, apply travel20, another 20% off. And then I send this request again, another 20% off. You see the manipulation in the logic. So you were supposed to only get 20% off, now you're traveling for free. Someone is abusing because the developer didn't think about this use case, someone manipulating the application like this, but someone is able to travel for free, basically, by abusing the logic of the application. No WAF, no other solution is able to protect it because the request, it's legitimate. You're just repeating or abusing the logic of the application. But let's talk about real-world cases. McDonald's. Everyone knows McDonald's, very big. They invest probably a lot in their application development. We would think they have very good applications, everything is secure, properly configured. But even they suffer breaches. So just to quickly run you through, basically the attackers were able to, first get a foothold because the developers forgot to change the password. First mistake, okay. But after that, this account was supposed to only access some test environment. That's why they didn't change the password. It was a test environment. There was no real user data there. But what they didn't do is validate that this test user can get actual production user data. And what the attackers had to do after they had access, they just had to repeat the API call to get the API v1 candidate user ID. So just change the user ID, repeat this call thousands or millions of times until they hit a proper user ID and get personal information from McDonald's candidates. Basically, they were getting the CVs. This was a huge breach, and no solution at that time was able to detect this. Why? Because the request, it's legitimate. The account is okay, and it's just trying to get different user IDs. But it's manipulating the business logic, because the normal logic is the administrator gets in, checks the candidate, approves the candidate, or says this candidate can't get a job. This is the normal workflow. They were doing something like the administrator logs in, and then they're just getting information of each user, manipulating the business logic. That is something we can do. That is something that is able to be blocked. Another use case, also Uber. Everyone knows Uber. Very big company. I would say a lot of funds went into developing their application. They also had a huge breach. Driver details were leaked. And how did they do it? Again, the attack went like this. Anyone can register as an Uber driver. You install the application, you register as an Uber driver, put the information, and you get your driver IDs. Once you register in the application, what happens? You register. After registering, you do a get call basically to get your driver details. And in the get call, in the user ID, it's your user ID. In my case, maybe Emma Baban. What they did, they repeated this get call with their JVT token and just changed the user ID to another user, until they were able to get driver details of all the drivers on the Uber platform. Because nobody was validating that my user, which I registered with, is able to get information from another user. I shouldn't be able to do that. But of course, the developers forgot to check this. They were able to manipulate it. And very easily, just by repeating one call, they were able to get all the personal information of drivers, like cars, drive IDs, personal emails, phone numbers, and stuff like that. That is something, again, because the requests are not malicious. The requests are legitimate. No WAF is going to be able to protect it, to detect or block it, because they're manipulating the way the application is working, where actually the application is not configured properly. But they're manipulating, finding these exploits, and manipulating the way the application is working. So these are basically business logic attacks. And how can we protect it? By having something that's called API security. Keep in mind, this is not API protection. A lot of people say we have API protection. API protection is only protecting known APIs. API security is a lot broader. Let's put it like this. This is API protection, and all of this is API security. But to go over each of these pillars, so to have a comprehensive solution that's able to detect these embedded attacks, business logic attacks, DDoS attacks, we need to have different procedures and engines in place to first, and this is the most important part, to detect and discover the endpoints. As I said in the beginning, APIs are very cool because they are very structured, and each application that's API based has something called an open API or a Swagger file. Maybe you heard of it. Think of it like a rule book, a cookbook that says these are all of the endpoints and this is exactly how they are configured. And the main problem here is you have this rule book, but no developer is actually keeping it up to date because it takes time from their development to keep up the documentation. Nobody likes to do documentation. So nobody has this rulebook, but you can have it. And with this rulebook, you can clearly enforce all of the endpoints. What we can do with this API discovery is basically build the rulebook for you. From live traffic, we'll learn all of the endpoints of your application. So each endpoint and how it's configured. And not only that, we also learn the sequence. So this is something called Business Logic Sequence Explorer. So you can basically see not only the endpoints, but what is the sequence of endpoints being called. So let's think of the Uber. We learn the sequence. When a driver registers, he gets his driver ID, then he accepts a ride, charges it, logs out. That's a normal workflow. If a driver registers, gets his user ID, and that just keeps getting user IDs. That's not the normal workflow. Something is wrong here. That stuff we can detect. So we have the discovery. We're able to discover endpoints, even the logic of each application. We have the protection, the runtime protection, so we can protect, again, as I was telling in the beginning, authentication bypasses, or if some endpoints are not authenticated or are not checking for authentication, we can alert on this and block it. We can do, of course, rate limiting per endpoint. We can do, so basically this is the WAF part of the API security, just one small part, so the detection of the payload. We can enforce the schema, the open API file, as I said, we can learn the rulebook and we can enforce it. So we allow only traffic that we know is good. All other traffic is bad and we can block it. And this is what sets us apart. We can do this business logic protection. As I was mentioning the business logic attacks before, because they're very hard to detect, because it looks like legitimate traffic. They're just manipulating the logic, and this is for each specific application. So you need to learn the logic of your specific application to build the rules to block it. Basically how it works, as I said, we have the sequence explorer, so we can learn the sequence of API calls in legitimate traffic. And then if someone is doing something like scraping, so it's logging in, it's posting something, and then it's repeating a request, we can see it's breaking the flow from the legitimate. Or if someone is trying to do an account takeover attack, trying to just spam the login, we can detect stuff like that because it's breaking the business logic. So here we can quite clearly see how the solution is able to detect business logic attacks. On top of this, so we have the discovery, the runtime protection, but we also do posture check and posture management. So not only looking at stuff that are attacks, we're also looking at how the application was developed and configured. So we're able to detect, again, to give you some examples. I think we have 5 more minutes. Balint. How the applications are configured. To give you some examples, a lot of times developers are putting the username and password in the URI headers, or are not using the authorization token. And it's not good because they're sending the username and password in plain text in the URI. So we can see it in the logs quite clearly. It's going like /login /user !user equals baban password equals 123. And you can see it in the log. And that's how the applications work. We can tell you, okay, this is probably not the best way to do authentication. Change it. We can't block it because that's how the application is working. If you block it, nobody will be able to log in. But we can detect stuff that is misconfigured and alert you on that. This is basically just how the platform looks on the GUI. And everything I was talking about now, it's not just me or Radware saying it. It's OWASP. So when you look at the OWASP security top 10 risks, especially the number 1, so the broken object level authorization, this is what happened to Uber, to McDonald's, with users that were getting other people's information from other objects. This is the main risk. And the only way to protect from this is with a solution that has business logic protection. So when you look at the top 5, we don't see WAF anywhere. If you look at the other 5 from the top 10, where WAF, as classic WAF, will be able to protect you is 1, 2, 3. So 3 out of 10 from the OWASP top 10, if you have a WAF solution. And of course, this API security is just one, let's say, small part, crucial part of our security platform. So the API security is one part. Of course, in the security platform, we have WAF, bot, client-side, LLM, agentic AI protection, DDoS protection. Basically, what we built is one solution. If you have an application that's exposed, you put it on our platform, and we're able to protect it from the layer 3, layer 4 DDoS attacks to the layer 7 application DDoS attacks, API attacks, WAF, bot, everything. You put the application on our platform, we protect it completely. And one of the main issues we have in the region is, this is cloud, it's using cloud. But you don't have to deploy it as cloud native, so you can use it as a cloud platform, run it through our cloud. So we're terminating the connection. But we also can do it out of path. Think of it like security on top of your infrastructure. If you're using our load balancers, or maybe a lot of you here are using F5, Nginx, Envoy, Hub Proxy, we have connectors for them. So let's say you're using an F5 load balancer, we can put security on top of F5. Use the F5 as a load balancer, use our security platform on top of it. Basically what happens, the client is still connecting to your firewall, to your data center, to your F5, to the backend server. It's just the F5 is just through our connector sending a copy of the traffic of each request to our cloud for the protection, for the analytics, and we're again blocking it on the on-prem infrastructure. So you're using cloud just on top of the on-prem infrastructure. Okay? Basically, that's it. Go enjoy your lunch. Sorry, it took a bit longer.